Zoom node. This chapter is a step-by-step walkthrough on setting up a Zoom node with an anynode. We will start with the initial setup process that involves the anynode scenario wizard with its guided setup that includes Zoom node type, network controller, ports, NAT Traversal, certificate, region, proxy targets, incoming and outgoing rewrite rules, node name, and node overview. Zoom node configuration. Once you start the assistant, it will guide you through setting up the selected scenario's node configuration. The Node Interconnection Assistant takes care of the configuration process step by step, making sure to highlight any incomplete steps with a red exclamation mark on the left menu. On the right side, you'll find input forms where you'll need to provide user-specific or system-related inputs, which the assistant doesn't handle automatically. Once you've filled out a form correctly and completely, it will be marked with a reassuring green checkmark. We recommend following the configuration in the order prescribed by the assistant. However, it is also possible to start the configuration at any point or select individual configuration steps directly from the left menu. To configure the node settings, simply choose Configure. Zoom node type. There are several options available to specify the type of Zoom node. The most common and straightforward method is Zoom phone premise peering. With the Zoom Contact Center option, businesses can establish virtual call centers that seamlessly integrate voice, video, chat, and email channels, allowing agents to interact with customers using their preferred communication method. Zoom Phone Provider Exchange is a platform by Zoom that allows selecting PSTN provider partners and utilizing telephony services through Zoom Phone. Choose the Zoom Phone Premise Peering environment and hit Next to move forward. Network Controller. The network controller in Zoom Phone Premise Peering configuration acts as a bridge between the PSTN and the Zoom phone system, enabling routing of traffic and ensuring connectivity between them. You will need to configure some network-related settings for the node. Since no settings or relationships are initially set, you need to select the option Create New Network Controller from the available network options. Once selected, you must configure the appropriate network interface settings. In this example, the commonly preferred option is Use an Interface's address with IP version 4. Choose the Ethernet interface that is listening to the public IP address, which is set as trunk group in Zoom. Zoom Phone Premise Peering supports both IP version 4 and IP version 6 for communication and connectivity. The specific configuration depends on the network settings and requirements in the peering configuration. For more advanced network controller settings, you can choose the Advanced Configuration option. These settings can be reviewed or modified later in the network controller dialog of the respective node. If everything is set as desired, proceed by clicking Next. Ports. In the configuration of a Zoom node in Zoom Phone Premise Peering, ports play a crucial role in facilitating communication between different components of a system. In this dialog, you can assign local port values for UDP, TCP, and TLS on the node. The SIP TLS port is by default set to 5061. The unrestricted UDP TCP port range must be set to the local requirements. Make sure these port values align with the network and remote configurations. If multiple nodes and network controllers in any node share the same local Ethernet interface and IP address, it is crucial to use unique port ranges to prevent port collisions. Keep in mind that the restricted ranges for dynamic UDP TCP ports should be at least 3 times higher than the maximum concurrent sessions to ensure optimal functionality. Click Next to proceed. NAT Traversal. Depending on your local network requirements and routing, you can specify the appropriate NAT Traversal settings. A prerequisite for communication with Zoom is the utilization of a public IP address. However, if any node, as in our example, operates behind NAT and possesses only an internal IP address, the externally accessible IP address of any node must be configured within NAT settings. The simplest method is to enter the publicly accessible hostname instead of the public IP address with Activate NAT Traversal. In our example, this is sbc6.lab.anynode.de. To continue the configuration, hit Next. Certificate source. In this setup step, you must configure a certificate, which is mandatory for a TLS connection. To provide this node with a certificate, you can either upload a certificate manually or let any node acquire it automatically using a certification issuance service. It is important to note that the certificate must include the valid SBC FQDN. Trusted certificates can be generated and renewed automatically within any node's frontend, including the option to do so without incurring additional costs, especially when using trusted certificate authorities like Let's Encrypt or ZeroSSL. For our example, we will order a certificate from the certification issuance provider Let's Encrypt. It is worth noting that any node accepts any certificate format and will convert it internally into the correct one if you manually upload a certificate. Simply click Next to proceed. ACME Account. The Node Interconnection Assistant will create an account for an ACME service like Let's Encrypt. But for other services like ZeroSSL or GoDaddy, an external account with an identifier and key is required. You need to enter an email address at this point. We advise against using disposable email addresses, such as user@example.com, as they are detected and rejected by Let's Encrypt. In such cases, the certificate retrieval cannot be completed. Consent to the terms of service is a prerequisite for using all ACME services. Click on Next. Certificate. To order a certificate from Let's Encrypt, it is necessary to provide the common name, which should be the FQDN of the SBC. Additional options such as subject alternative names or the signing algorithm can be configured by clicking the edit icon. Enter the FQDN of this SBC here. Click on Next. HTTP challenge. To obtain a certificate from the ACME service, their servers verify that you have control over the domain for which the certificate will be issued. This validation process is automated through any node. Any node must be reachable via port 80, but it will only listen on that port during the certification issuance process when necessary. Therefore, port 80 needs to be opened in the firewall as well. Please choose the interface/IP address that should be utilized to address the challenges. Click on Next. Region. Please select the data center from which you have received the access data from Zoom. If your data center is not available, click on Others and add the Zoom proxy servers by hand. In this example, the chosen region is North America, which specifically corresponds to the US Zoom data centers. The EMEA region function in Zoom Phone Premise Peering configuration selects data centers in Europe, Middle East, and Africa for handling specific targets, ensuring optimal performance and compliance. The upcoming assistant dialog will address the relevant targets associated with the selected region. Hit Next to proceed. Proxy targets. Proxy targets are necessary to facilitate communication between any node and the Zoom Phone Cloud service. The Node Interconnection Assistant has already set proxy targets based on the previously determined region. Click Next to continue the configuration. Incoming and outgoing rewrite rules. You can enter dial string rewritings here. These are necessary for instance, to convert incoming calls to anynode into the E.164 format or outgoing calls into another desired format. Since no incoming or outgoing rewrite rules are required, we can skip the following dialogues. To move on, click Next. Node name. This input form creates the name for the Zoom node, which is customizable. This designation of the node name is also used for the routing domain and dashboard entries later on. Use always a unique identifier for the name. The assistant suggests a name for you. You have the flexibility to change the default node name as desired. Here, we will proceed with the suggested name. Once you have done so, simply click Finish. Node Overview. After completing the configuration, the Node Interconnection Assistant will display an overview of your settings. The certificate retrieval through the ACME service will be performed later, after the completion of the entire wizard. If everything is correct, select Next to proceed with the configuration of the second node for this scenario.